In this demo we showcase AES Service Topology Design Studio, Service Deployment, AES CMDB Inventory and End-to-End Connectivity Diagnostics Testing. First, we design an end-to-end edge-to-cloud connectivity service using the Design Studio. Then AES will deploy resources at the Equinix Dallas Edge Data Center and the Azure Region West US. Create a new topology by giving a name, description and a notification email ID. AES Interactive Map Service enables users to select edge locations and public cloud regions. Let us select Equinix Dallas Edge location and Azure Public Cloud region as West US Silicon Valley. Now, let us input Equinix Metal resource attributes such as flavor, VLAN, hostname, instance count, OS type and SSH information. Drag and drop the resource in the Design Studio. We will also create a network edge device Cisco C8000V VNF at the Dallas Edge location. It will be used to create a private interconnect between Metal servers and Azure Public Cloud. Let us input the VNF hostname, package code, license key, interface count, ACL, ASN and SSH access details. Drag and drop this resource into the Design Studio. At this point we only have the Equinix Metal and Network Edge VNF in the Design Studio. Now, we will design the Azure Public Cloud private connectivity using ExpressRoute. Input the Azure ExpressRoute details such as resource group name, bandwidth, peering ASN and VLAN CTAG for the private connection. Make sure that we input the shared secret to be used for BGP sessions between the Edge router and Azure ExpressRoute. Drag and drop the ExpressRoute into the Design Studio. Now the AES Design Studio has the Metal server, C8000V router located at Equinix Dallas Edge location and the Azure ExpressRoute located in Silicon Valley. Let's create an interconnection between Metal servers to the C8000V with connection speed 100 megabits per second and a private interconnection between C8000V and Azure ExpressRoute. Save the service design into AES CMDB to complete the design phase. AES will now automatically deploy and configure Metal servers, C8000V router at the Dallas Edge location and will deploy the Azure ExpressRoute in Silicon Valley with a private connection to the Edge router C8000V. Now let us take a look at the provisioning status in the AES UI and AES Workflow Engine logs. It will take a few minutes to deploy all resources and create interconnection between all three domains. You can see that the service deployment status is in progress now. We verify the end-to-end service deployment status by first logging into the Azure portal where we see that the ExpressRoute state is still not provisioned. Checking the emails from Equinix, we see that the Equinix Network Edge device is successfully deployed and the interconnection DA to DA is provisioned. The private connection from Dallas to Silicon Valley is now complete and we should see the Azure ExpressRoute state transitioning to provisioned state. AES discovers provisioned resources and interconnection details in the CMDB graph database. We use REST APIs to verify information from the CMDB. First, verify the discovered Metal VLAN and server instance details. Second step is to verify the Equinix Network Edge VNF C8000V discovered details. Here we can see the package code, hostname and other details. We can see that details about VNF Gigabit Ethernet 3 connected to Metal server and the Gigabit Ethernet 5 connected to the Azure ExpressRoute. Let us also review the Azure ExpressRoute discovered information such as name, resource group, local ASN and the peer ASN of C8000V Edge router as well. Let us verify the connectivity information and the latency details from each domain. First, verify the Edge router C8000V interface and BGP configuration and latency details. Second, execute ping tests from Metal server to verify if we can reach Azure ExpressRoute. Log in into the C8000V Edge router and verify the running configuration. Look at the L3 configuration of the interface Gigabit Ethernet 3 towards Metal Server 24 subnet. Review the L3 configuration of the interface Gigabit Ethernet 5 towards Azure Express Route 30 subnet. Also we can see that BGP session is up between Azure Express Route with remote ASN 12076. Execute ping test to Azure Express Route IP 173.23.42.230 confirms the latency between Dallas and Silicon Valley is around 30 milliseconds. And the latency between C8000V router to Metal server is less than 1 millisecond. Now let us log into the Metal server and execute ping diagnostics. First verify that AES has configured the bond 0.1654 interface with IP address 10.0.0.0.9 from the IP pool. Second, verify that we have all static routes configured to reach the C8000V router and Azure Express route. Pinging the C8000V router interface 10.0.0.0.8 took less than 1 milliseconds. Pinging the Azure Express route IP address 173.23.42.2 took close to 30 milliseconds. This is the latency between Dallas Edge DC location and Azure Express route Silicon Valley using the private network connectivity services. This demo concludes that AES greatly simplifies orchestrating resources at multiple edge locations and public cloud connectivity.